Hi guys, welcome to my channel. In this video, I'm going to talk about two questions for elastic collision in one dimension. The first question, a particle A of mass m is moving with speed 3u in a smooth horizontal table. Okay, smooth, which means no friction. When it collides directly with a particle B of mass 2m, which is moving in the opposite direction with speed u. The direction of motion of A is reversed by the collision VA, and B, put it VB. The coefficient of restitution between A and B is E. Okay. Since the question didn't state the direction of VB, so we can assume that it will go towards the right. Let's take everything to the right as positive. So A, show that the speed of B immediately after the collision is 1 over 3 1 plus 4e bracket u. So first we're going to use conservation of momentum. So MA UA plus MB UB is equals to MA VA plus MB VB. So MA is M and UA is 3U plus MB 2M, and UB is minus U since it's going to the left, equals to M times minus VA because it's going to the left plus 2M times VB. And we can eliminate the M, so we get 3U minus 2U equals to minus VA plus 2VB. So U will be equals to minus VA plus 2VB. Okay, so this is our first equation. Now, how do we find the second equation? So the second equation, we can use Newton's law of restitution, whereas E equals to, okay, here. So after the collision, since they are moving away from each other, so you will feel that the particle will move very fast. So it's VA plus VB. And how about before the collision? Before the collision, they are moving towards each other. So you will also feel that the particle will be moving really fast. So it's 3U plus U. Okay, so E equals to VA plus VB divided by 4U. So VA plus VB will be equals to 4EU. This is the second equation. Okay, now, since they want us to find the speed of B, right? So we can eliminate A. How? We can try to use the second equation plus the first equation. So which means we get 4EU plus U, and then VA plus minus VA, which is 0, and VB plus 2VB, which is 3VB. So by factorizing the U, we get 4E plus 1 equals to 3VB. So the velocity of B is 1 over 3 4E plus 1 bracket times U. Yep, which is the answer. So B, they say show that E is equals to E larger than 1 over 8. Here we need to find VA first. So we can sub VB into the second equation. So VA plus 1 over 3 4E plus 1 times U equals to 4EU. So VA plus 4 over 3 EU plus U over 3 equals to 4EU. So VA will be equals to 4EU minus 4 over 3 EU minus U over 3. 8 over 3 EU minus U over 3. And and by factorizing u over 3 we get 8e minus 1. VA will be larger than 0. Because we already assumed that VA has a minus sign because it's going to the left, so the value for VA must be positive, cannot be negative, because if it's negative we will get positive for our VA in question A. 8e minus 1 will be larger than 0, and 8e larger than 1, e will be larger than 1 over 8. Okay, subsequently, B hits a wall fixed at a right angle to the line of motion of A and B. The coefficient of restitution between B and the wall is 1 over 2. After B rebounds from the wall, there is a further collision between A and B. Okay, so first, we know that there will be a wall which is right angle to the line of motion of A and B is moving towards the wall with the velocity of 1 over 3 1 plus 4e times u. So this is the velocity of approaching, and the question did say that e is 1 over 2. So first we can find the speed of rebound, which is WB. So WB divided by VB. WB will be equals to VB times E. Since E is 1 over 2, so 3 4E times 1 over 2 will be equals to 1 over 6 1 plus 4E times U. Okay, and then it says after B rebounds from the wall, there is a further collision between A and B. So A and B will collide again. Okay, since we know that A will be moving to the left with the velocity of u over 3 8e minus 1, and B, after it rebound, it will move with the velocity of WB. So in order to have both B and A to have a second collision, we must make sure that the velocity of B will be faster than the velocity of A in order to catch up and collide with A. So we know that WB will be larger than u over 3 8e minus 1. Since WB is 1 over 6, 1 plus 4e times u over 3 e minus 1. So here we can eliminate u and 2 here. So 1 over 2 1 plus 4e 8e minus 1. So 1 plus 4e is larger than 16e minus 2. So 3 12e. So e is smaller than 1 over 4. Yep. Okay, now we have the second question here. 3 identical particles A, B, and C lie at rest in a straight line on a smooth horizontal table with B between A and C. Yep, so my diagram is correct. The mass of each particle is m. Particle A is projected towards B with speed u and collides directly with B. So the coefficient of restitution between each pair of particles is 2 over 3. So whenever they collide, the coefficient of restitution will always be 2 over 3. Okay, so A. Find in terms of u the speed of A after this collision. Okay, so let's consider A and B first. So after they collide, they will have velocity of VA and VB. And let's assume both of them is going to the right. And take right as positive. So B is at rest, so UB will be 0. Okay. Since they want us to find the speed of A first, so we can eliminate B first. So by using 1 minus 2, so U minus 2 over 3U is 1 over 3U equals to VA minus VA, which is 2VA, and VB minus VB is 0. So VA will be equals to 1 over 6U. So since we found VA, so VB will be equals to VB minus 1 over 6U equals to 2 over 3U. So VB will be equals to 5 over 6U. So for B, show that the kinetic energy lost in this collision is 5 over 36 mu squared. To find the kinetic energy loss, we need to use kinetic from the initial minus the final kinetic energy. The kinetic initial is actually the kinetic energy of A only, because B is at rest. So will be half mu squared. And the kinetic energy final will be the kinetic energy of A and B. And in here we don't need to care about the positive or negative sign, because after you square, all the negative will be positive anyway. Square. So the kinetic energy loss is equals to half mu square minus 13 over 36 mu square, which is equals to 5 over 36 mu square joule. Yep, which is the correct answer. So C, after the collision between A and B, particle B collides directly with C. Okay, so find in terms of U the speed of C immediately after this collision between B and C. So here I will draw another diagram. And C is at rest, and B is moving with the velocity of 5 over 6U. And after the collision, B will maybe moving still towards the right. Let's assume that. And C is moving towards the right too. So we call this a WB and WC, because we use U and V already. So we can use conservation of momentum. This is the fourth equation. Since we want to find WC, right? So we can eliminate B by using equation 3 plus equation 4. So what we get? 5 over 6 plus 5 over 9, which is 25 over 18U, is equals to WB minus WB, 0, and 2WC. So WC is equals to 25 over 36U. So that's all for this video. If you did learn something from this video, which I really hope so, please leave a like and subscribe to my channel. And I will see you in the next video.